Welcome back. In this video, we are going to look at another exam type question. Show that sine to the power 4x plus sine squared x times cos squared x over cos squared x minus 1 equal to minus 1. It looks like a quite complex equation, but we can prove it easily. Before we start proving it, let me write down our trigonometric identities. For this example, we don't need tan x. We need the second identity, which is sine squared x plus cos squared x equal, right? So what is sine squared x? If we make sine squared x subject, this would be 1 minus cos squared x. I'm going to multiply by minus both sides. So therefore, minus sine squared x equal to cos squared x minus 1. So we need this formula. And you can see cos squared x minus 1 equal to minus sine squared x. Now, if we come back to our original question, we are going to start with left hand side. And we are going to prove that left hand side equal to right hand side. The numerator, sine to the power 4x. Sine to the power 4x is nothing but sine x times sine x times sine x times sine x. So if you multiply sine x 4 times, then it will be sine to the power 4x, right? But we can split the sine to the power 4x into sine squared x times sine squared x. So let me rewrite the left hand side. So left hand side, sine 4x is going to be sine squared x times sine squared x plus sine squared x cos squared x over cos squared x minus 1. In the numerator, I can take sine squared x as a common factor. Sine squared x will be sine squared x plus cos squared x over cos squared x minus 1. We know from our first identity, sine squared x plus cos squared x equal to 1. Therefore, this is equal to 1. So we will left with only sine squared x in the top. In the numerator, cos squared x minus 1. So cos squared x minus 1, look, we proved that cos squared x minus 1 is equal to minus sine squared x. Therefore, this is equal to minus sine squared x. Voila! Sine squared x divided by minus sine squared x equal to minus 1. This is equal to right hand side of the equation. That concludes the proof. Thank you. Please move on to next video.